Alright, so we're going to use our knowledge from right triangles to solve for x and y in each triangle. Knowledge could be the SOHCAHTOA, could be Pythagorean theorem. That's all we really know. These are all right triangles. I don't have the little triangle or the little 90-degree angle measure here on all of them, but they're all 90-degree angles. And so we look at the very first one, and we have a 30-degree angle here, and this side length here is 1. So the side length is 1, that's 1 unit. We don't know what the units are, we just call it units. And so in this case, first you always got to start labeling. So the 1 is the hypotenuse. Across from the 30 is the opposite side, and adjacent next to it is the x. So you can start by finding y if we want. So y is opposite over the hypotenuse, so we're going to do sine of 30 equals y over 1. So to solve for y, it's pretty easy. Multiply by 1. You get y to equal, and in the calculator, make sure when you turn your calculator on, it's in degree mode. So go to mode, we can see it's in degrees, so we're good. So we're going to do sine of 30. And it gets 0.5. That's exact, so we can keep that. So 1/2. So we know that the y here is equal to 1/2. Now to find x, so if we do the exact same thing, we're going to do the adjacent now over the hypotenuse. So it's adjacent over the hypotenuse is the cosine of 30 equals the adjacent over the hypotenuse. So again, looks pretty easy. Multiply by 1. And we do cosine of 30. Cosine of 30 equals... oh, that's not an exact number. So we can't write that down. We need exact values. So 0.8661 or 0.25. It's not exact, so we can't write it down. So we got to scratch that. So we need a different way of doing this problem. Well, another thing you remember, hopefully, about these triangles is Pythagorean theorem. If you have two sides given to you, you can find the third. So we can do it. We have two sides. And so Pythagorean theorem is one side squared plus the other side squared is going to equal hypotenuse squared. So 1 squared. And just add a temp at parentheses. Let's simplify this down. X squared. We have 1/2 squared. 1/2 squared is, so you square root the numerator, square root the denominator, and it's going to equal 1/4. And 1 squared is 1. Subtract 1/4 over, you get x squared equals 3/4. And you square root and square root. And when you simplify this, you get the square root of 3 over the square root of 4. And you can never have the denominator have a square root in it, so we got to get rid of it. In this case, it's just a perfect square root here. So you just, square root of 4 is 2. So that's good. Square root of 3 over 2. That is what x is going to equal here. Which, if you put it back in your calculator, you, like me, and sometimes don't trust your math. You just want to check it quick. Square root of 3 divided by 2. It's got to come up with the same thing. Alright, it does. Cool. That's the answer. So 3 over 2. Square root of 3 over 2. Over here. So we can label it. Start off by labeling it. So here's the angle. Across from that angle is opposite and the hypotenuse and adjacent. So if we want to find y, it would be sine of 45 equals y over 1. Multiply by 1 and you get y to equal, let's look, so sine 45, uh-oh, that's not a nice decimal. That's not an exact number. It's an irrational number. There's nothing to repeat, so we can't write it down. So scratch that. That ain't gonna work. Now we have to figure out some other knowledge we have about this triangle. Well, so this is a 45, 90. This angle over here is 45 also. Hopefully there's something special about that you remember. If you have two angles that are the same here, these sides are also the same length. So x and y are the exact same length, so we don't need to use a different variable for them because they're exactly the same. So let's just make, instead of that being y, let's make it x. So now we have two x's. There's length x, and we can use Pythagorean theorem. X squared plus x squared equals 1 squared. X squared plus x squared is 2x squared. 1 squared is 1. Divide by 2. You get x squared equals 1/2. When you square root this, you're going to square root the numerator and the denominator. And square root of 1 is 1. That's nice. But the square root of 2, we can't do it. You can't simplify that. But we cannot have a denominator with a square root in it. So what you do is you rationalize it by multiplying by the square root of 2 over 2, the denominator. And what that happens is you get 1 times the square root of 2 on the numerator. Square root of 2 is good. Square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. So that means our x is going to equal to the square root of 2 over 2. So both of these sides is the square root of 2 over 2. And you're saying, alright, how does this apply to what I saw in class today? Well, let's look at this graph here. Cartesian plane, coordinate plane. It's going up by, in this case I have it going by halves. It can go by anything. But if you have this thing called a circle, and the circle has a radius of, say, 1, so the radius here is 1, we can figure out this coordinate right here at 1, 0, and say like this coordinate here. At this time, all students. This point up here is at, a point is easy to find at 0, 1. Point to the left here. If you go left, you're going left 1, so negative 1, 0. And down below here, this is the coordinate 0, negative 1. So those are easy. What happens if you get an angle, say, that goes right through here? And you want to find out that point. Doesn't match up nice and neat with x's and y's. So we got to figure out this coordinate. Let's just say that this is a 30-degree angle. It's a 30-degree angle. We can find this. And you're like, well, how do I do it? If you go straight down, draw a straight down line, and it's a 90-degree line, we have a 30, 60, 90-degree triangle. But if you look back, we have a 30, this is 60 here. 30, 60, 90 triangle right here. Just because it's not on the coordinate plane doesn't mean that they're the same thing. So both those triangles are the same. So we have the radius of the circle all the way around is 1. So you can figure this out with SOHCAHTOA or the Pythagorean theorem. So you have the x value here is the square root of 3 over 2. That's x left to right. So that's the same as this right here. So we're going square root of 3 over 2 to the right, which is our x values. And up, if we look back, the y here that we figured out was 1/2. So it's going to be 1/2. Sorry. Positive 1/2. That's supposed to be a positive. Now it's like, well, what if we have a different angle? So now if we have an angle, say, that goes through here, that's not a very good line, but Say it's a 45-degree angle. Now what? If we look back, we actually just did that. 45-degree triangle. What it'll make, and remember square root of 2 over 2 for both x and y. We have triangle, and so again the radius is 1, so this coordinate here, if you look back, it's a square root of 2 over 2 for the x and square root of 2 over 2 for the y. And you do this again for the 60 degrees, and if you want to look back, it's going to be 1/2 for the x and the square root of 3 over 2 for the y. And this will keep, this pattern continues on and on and on, and you'll see that it'll go all the way around, and you will end up getting this. You'll get all these special points for the unit circle. You don't have to memorize them this year. Next year you will, but hopefully this helps you. Thank you.